For today's lesson, we will be discussing about rational functions. So let's define first what is a rational function. A rational function can be written in the form f of x equals n of x over d of x, where n of x and d of x are polynomials and d of x is not the zero polynomial. This means that the numerator and the denominator of our rational function must be polynomial, and the polynomial on the denominator should not be equal to 0. Because as what we know, if the denominator is 0, it will become undefined. So please take note of that. Now we have what we call as the zeros of rational function. So it is the value of x of the function that will make the numerator 0 without simultaneously making the denominator equal to 0. So this means we're trying to identify values of x, or our input, okay, that will make our output equal to 0, or that will make our function equal to 0. But take note, the denominator again should not be equal to 0. Because if it makes the denominator equal to 0, then it's not considered as zeros of the rational function. We also have the intercepts of the rational function. So there are two. So we have the x-intercept and the y-intercept. Okay? So when we say intercepts, these are the x-coordinates or y-coordinates of the points at which a graph crosses the x-axis or the y-axis respectively. So these points is where the graph touches our x-axis and our y-axis. So we're going to identify the following x-coordinates and y-coordinates. So first is we have the x-intercept. It is the x-coordinate of the point where the graph crosses the x-axis. So let's say we have a Cartesian plane. And let's say we have this line right here. Okay. For example, now this point of intersection of the graph and our x-axis, that will give us now the x-intercept. Okay? Again, we have to identify what value of x, or what is the x-coordinate of the point where the graph crosses the x-axis. For the y-intercept, it is the y-coordinate of the point where the graph crosses the y-axis. So it's now the y-coordinate. So let's say again you have the coordinate plane or Cartesian plane, and then let's say we have this graph right here. Just an example. And then this point of intersection of the graph and the y-axis, so we have to identify the y-coordinate of that point, and that will give us now the y-intercept. Now let's try to determine the zeros and intercepts of the following function. Okay, let's start with the first one. F of x equals 2 over x minus 1. Again, we have to identify the zeros and the intercepts of this given function. So let's try to identify first the zeros. Again, when we say zeros, that means these are the values of x, or these are the input that will make our output equal to 0. So we're just trying to identify the values of x that will make our function equal to 0. With that in mind, that means in order for us to identify zeros, we have to set f of x equal to 0, or we have to set this whole function equal to 0. Okay? Because again, we're trying to identify what value of x will result or will give us an output which is equal to 0. So again, instead of f of x, we equate now the whole function to 0. Then we have 2 over x minus 1. And then from here, just solve for the value of x. Okay, so we have here now 0 equals 2 over x minus 1. Now to solve this, since we have here a rational function, so there's a denominator, just multiply both sides by the denominator so that we can remove it there. So this will be cancelled. Now x minus 1 times 0 is just 0. Equals, and then since we cancel out x minus 1, so we're left with 2. Now notice, after cancelling out our x minus 1, we only have 0 equals 2, which is obviously not true or incorrect. So this means that there is no zeros. Okay? meaning there is no value of x that when you substitute to this function will give us an output which is equal to 0. Okay, so if it happens that your solution becomes like this, that means there are no zeros. Okay, this function doesn't have any zero because there's no value of x that will give us a value of the output which is equal to 0. Now for the x-intercept, we know that this is where the graph touches our x-axis. And if a point is at the x-axis, that means the y value or the y coordinate is equal to 0. So in order for us to solve for the x-intercept, we just have to set the value of y, which is 0, or our f of x be equal to 0 because they're just the same. Okay? So if we will replace f of x or y with 0, we will still get 0 equals 2 over x minus 1. Again, when solving for x-intercept, we set y to 0 or our f of x to 0. Again, if we're solving for the x-intercept of a given function, we set y to 0 or the f of x equal to 0 because all the points in the x-coordinate has a 0 value for their y-coordinate. Okay? So we have here now 0 equals 2 over x minus 1. Now notice, this is just the same with our solution for zeros. So that means if I multiply again both sides by x minus 1, so this will be cancelled. Still, we will get 0 equals 2. That means there's no x-intercept. Now, if you will look closely at the steps in getting the zeros and the x-intercept, they are just the same. We set f of x equal to 0 or y equals to 0. Okay, so that means the zeros and the x-intercept are just the same. So whatever values we will get for the zeros, that will also be our x-intercept. Now for the y-intercept, since these are the points along our y-axis, so that means we have to set now x equals 0 because the points in the y-axis, the value of their x-coordinate is 0. So again, we set it x equal to 0. So what we will have here now is f of x, or again we replace it with 0. And then 2 over 0 minus 1. And then just simplify this. 2 over 0 minus 1 is negative 1. 2 divided by negative 1, we get negative 2. So that means our y-intercept is negative 2. This is now the y-coordinate of the point where the graph touches our y-intercept. Or if you want to get the actual point itself, so we have 0, negative 2. Okay, so if x is 0, then our y is a negative 2. So this is our answer. So for our answers, zeros, there's no zeros. X-intercepts, no x-intercept. And then for the y-intercept, we have negative 2. Let's have another one. G of x equals 3x minus 4 over 2x plus 1. So let's now solve for the zeros. So again, when we're solving for zeros, we just have to set our g of x or our function equal to 0. So we have 0 equals and then 3x minus 4 over 2x plus 1. Because again, we're trying to identify what are the values of x that will make our function equal to 0. So here, since we have a denominator, again, let's multiply both sides by the denominator, which is 2x plus 1. And then simplify. So this will be cancelled. 2x plus 1 times 0 is just 0. Then we're left with the numerator, which is 3x minus 4. Now from here, all you have to do is solve for the value of x. So we can move negative 4 on the other side. So we have 4 equals 3x. And then divide both sides by 3. So cancel. Therefore, we have x equals 4 over 3. So this is now our 0. So 4 over 3. So if the value of x is 4 over 3, that means our function will be equal to 0. And if you substitute it to the denominator, it will not be equal to 0 as well. Next, let's solve for the x-intercept. For the x-intercept, again, we set f of x, or in this case, we have g of x equal to 0. Since it's just the same, the steps in finding the zeros and x-intercept is just the same, therefore, we can say that our x-intercept for this given rational function is 4/3. Or, if you're asked to write it into coordinate points, so we have 4 over 3, 0. So if y is 0, or if x is 4/3, then our y will be equal to 0. So for y-intercept, so what we will do is we set x to 0. So we have g of 0 equals, then substitute 3 times 0 minus 4, and then we have 2 times 0 plus 1. So 3 times 0 is 0 minus 4, negative 4. 2 times 0 is 0 plus 1, 1. Simplify, we have negative 4 as the answer. So our y-intercept is negative 4, or for ordered pairs, we have 0, negative 4. So these are our answers. So 0, we have 4/3. X-intercept is 4/3 as well. Y-intercept is negative 4. And for our last example, let's have h of x equals x squared minus 5x plus 6 over x plus 5. So let's solve for the zeros first. So again, we set our function to 0, equal to 0. So 0 equals, and then we have x squared minus 5x plus 6 all over x plus 5. And then multiply both sides by x plus 5 to remove the denominator. Cancel. This will be equal to 0 equals. Then we have x squared minus 5x plus 6. Now from here, what we will do is we just have to identify the value of x. Now looking at this given expression or equation, this is now trinomial. So that means we have to do factoring in order for us to identify the values of x. So we have two binomials as the factors. So x squared, the factors of that will be x and x. For positive 6, identify factors of negative 6 that when you add, the answer is negative 5. So that will be negative 3 and negative 2. So negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. And then just equate both factors to 0. So therefore, we have x equals 3 and x equals 2. So these are now our zeros. So for the zeros, we have 3 and 2. Now for the x-intercept, so we set h of x equal to 0. So that means we're just getting the same answers as with our zeros. So we have for our x-intercept 3 and 2. Or if you will write them as coordinates, so we have 3, 0, 2, 0. Okay, so these are our x-intercept. And lastly, for our y-intercept, we set x equal to 0. So we have h of 0 equals 0 squared minus 5 times 0 plus 6 over 0 plus 5. So this is just 0 minus 5 times 0 is 0. So we're just left with 6. 0 plus 5 is 5. So we cannot simplify it even more. So our answer is 6 over 5. So our y-intercept is 6 over 5. Okay? And if you want to put it in coordinates form, so we have 0, 6 over 5. So this is now our y-intercept. So that's it for today. I hope you learned something about the rational functions and how to solve for the zeros, x-intercepts, and y-intercepts. And see you next time.